Hi guys, welcome to the channel. Today we are going to talk about some basics of integration and some tricky questions based on that. So I know that differentiation should be covered before integration because that's how it all begins. But then differentiation is slightly easier. So I just wanted to give a gist of integration first and then come back to differentiation. Before we start today's session, I'm Sunny Kapoor and I'm an NSIT pass out, now known as NSUT, and I've also done my MBA from Narsi Monji, Mumbai. I'm working in a bank right now, and maths being a passion, I'm following it, and I hope I can be of help of some of you, right? So, coming to the basics of integration, what we know is integration is basically anti differentiation, right? So anti-differentiation. This is one way of portraying integration. The other way is obviously which defines definite integrals, talking about limit of sum of the series whose each term tends to zero and the number of terms are till infinity, right? So differentiation basically gives you the tangent, the slope of the tangent to the graph of the function, right? Integration gives you the sum under that graph. So ideally they are both opposites. Now, in indefinite integrals, the answers to a particular problem can be innumerous. You can come out with another answer. I can come out with another answer. So basically, what you have to do is you have to think and then you have to just apply your basics. Trigonometry is going to be vastly used in these chapters. So I would recommend that you revise your trigonometry basics first and then proceed with the session if you haven't done that. Now, coming to integration, there are some basic formulas which we all need to first know. So, I'll just highlight a few formulas which will help you to start with the basics. Okay, so I have picked up these formulas from a book, but then I cannot mention which book. Uh, it's not a paid channel, guys. So if you want any queries regarding study material or books, I would be happy to help. You can contact me in the email address given on the channel. But then it's not a paid channel, so yeah, therefore, I'm not mentioning any of the books right now. Okay, I can or I might switch in between to Hindi as well. So just let me know if that is more convenient to you. So you can go through these formulas. These are very basics, and we need to know them. Don't need to by heart each and every formula. With the questions you solve, within more practice you do, you'll be able to learn them on your own, right? So starting with the basics, what I'll just do is I'll just take up a very small question. So starting with the first question. Okay, please don't mind my handwriting. Okay, so this is x plus 1, guys. Okay, I'll rewrite it for you. Okay, now as we can see, we cannot apply any of the formulas which I had given to you, but still, this problem is a relatively easier one. Uh, what you can do is you can pause the video, you can try it on your own, and I would urge every one of you to do that first. But yeah, this being a basic easy problem, uh, I'll just go with the solution. What we can do here is we have two under roots in the denominator. So first of all, having under root in a denominator and with a plus in between, we need to, you know, rationalize this given term. And once we do that, the denominator would be virtually easy to solve. So let's see what happens. So, uh, so this is our problem. So what I do is I rationalize it by multiplying and dividing with the same term, right? So what we get by this is the numerator remains the same, but the denominator be becomes plus 1 minus x, right? So now this becomes a relatively easy problem. You have x plus 1 to the power of half minus x to the power of half dx dx, and you can solve it ahead with the formula given, right? So this is one problem which is very easy, but then what you had to point out was we had to rationalize it, and then it was a cakewalk. So going to the next question, let's just write question number 2. So what we have here is a slightly different question. Now, taking this question, we see that we have x to the power of 4 in the numerator and x square in the denominator. If there would have been a negative sign in the numerator, then we could have factored it and the case would have been simpler. But now we don't have a, we cannot factorize it easily. So what we can do is we can basically write it as this. So what we did is we have added 2 and subtracted 2 in the numerator. So if we add and subtract a same number in the numerator, it doesn't affect the numerator. Now this makes it simpler for us because we have x4 minus 1 plus 2 upon x squared plus 1 dx, right? Okay, again this is messed up. So this is the first time I'm writing on a digital pad, guys, so just bear with me. Okay, now this is relatively easier to solve. What we have is we have this as the factors, we can separate it, plus we have 2 upon x squared plus 1 dx. Now we can solve this, right? This becomes an easy term to solve, and this, if you have seen the formula, is tan inverse x. Oops. Tan inverse x, right, plus constant. This will also come out to be, right? So that's how this question was. Now what we needed to do is just this minor change of adding 2 and subtracting 2 for our convenience. Now these tricks, if you get hold on, if you get your holds on these things, then integration will be a lot simpler for you, right? So we'll just take another question. Now this question, sorry. Now this question number 3, this says that we have this given integral and this is equal to tan of x by 2 plus a plus b, right? So we need to find out the value of a and b. Now in this particular question you cannot go by solving it in any method you want because the answer is specific over here. So now how do we take it in this form, right? We need to solve it in the form of tan. Now uh, tan we can see is uh, what when we get a derivative of tan's derivative, sorry, is secant square, right? So we need to form somehow secant square in the integral. Now we see that in the denominator we have 1 plus sine x, right? We can convert it into cos 2x formulas, but then if we do that we'll still have another numeral in the denominator. So what we can do is we can first convert sine to cos over here. Once we do that, we can easily write the denominator as okay. So that's what I said, guys. Our basics of trigonometry needs to be polished. What we see here is a formula of cos 2 theta, which says it's 2 cos square theta minus 1. Okay, and we just rearrange the terms, and that's how we get 2 cos square pi minus 4 minus x in the denominator. So finally we have got secant square pi by 4 minus x dx, which is the answer comes to as tangent of pi by 4 plus x by 2, right, plus c, right? So that's how we go about the question. Now next question. Now this question, guys, is a bit tough. We cannot just easily solve it because it applies a trick which we need to know first. So this comes only with practice. It's not about that you don't have the aptitude to solve the particular question, but then if you have not solved it beforehand, then it is going to be tough for you guys. And seriously, I need you guys to think over it. This question demands some thinking as to how we can approach it. Coming to the answer in the first class is not what we're looking at. We're just looking at how you approach it and how you go about it, right? So we can see in the numerator we have two cosines adding up, and we do know the formula of cosine adding up, but then will it help us? That is the question. That is what we have to think about. And let's see, let's try with that first. So if we just take the numerator, so this adds, and again guys, formulas So we need to have a grasp on trigonometry first, right? So what we have is cos A plus cos B is equal to 2 cos of A plus B by 2 into cos of A minus B by 2, right? So now we see that the numerator has cos 9x by 2 and cos x by 2, and the denominator is still haywire and we don't know how to solve it and how to go about it. So what exactly we can do? Uh, can we change the cosine in the denominator, or what we can do? So that is why, when you're not getting anywhere with the question, then the question challenges you, and this is the solution which we have to go about. Now what we do is we multiply by sine 3x, sorry, in both numerator and denominator. Why we did that is what I'll tell you in a bit. Let's see how it turns about. This is sine 2x formula, right? And we know the numerator, we have already simplified it. Let's see the denominator. The denominator becomes sine 3x minus 2 sine 3x cos 3x. Now this guy becomes sine 6x. And when it becomes sine 6x, we can again apply a formula of sine A minus sine B in the denominator. And that is how we have been able to remove this numeral, right? This was creating a problem because if we had sine or cosine over here, we could have easily applied the formula, but then that was not an option. So now what it becomes as is 2 sine 3x by 2 cos 3x by 2 into 2 cos 9x by 2 cos x by 2. I know guys, I've taken this question and it seems like we cannot solve it on our own if we don't know the solution, but not all questions are this like these. And if you have once solved this with your own hands, then you can also boast around saying that, see, I know this question, and people won't be able to solve it if they haven't done it, right? So that's how you fall in love with maths. Okay, so again we apply the formula. So finally what we get is 3x by 2 cos 3x by 2 into 2 cos 9x by 2 cos x by 2 upon, now this formula will become negative because sine 6x is of negative sign, cos 9x by 2 into sine 3x by 2. This term and this term gets cancelled, and this term and this term gets cancelled. So it basically just becomes minus cos 3x by 2 into cos x by 2 dx. And again, we can use the reverse formula. What we get is cos 2x plus cos x dx, right? And we can solve it further. So this was one question which was of a little bit higher level, but then why we did what we did here is, first of all, to remove the 1, and secondly, to make a formula in the denominator which will be able to cancel a few terms in the numerator. And that is how we got this question. Okay, now we'll go and solve one more question. Okay, now this is little bit easier, but then you still have to tweak it a little bit, right? And just a second, I'll just, yeah. So next question. The question is easy, guys, but just you have to just think a little bit and you will be able to crack it, I'm sure. Okay, so just take some time, have some water, breathe. This is not as tough as it looks like. The numerator is of the power of 8, the denominator is in squares, but they're multiplying. Okay, so let's begin. I hope you have solved it, and whoever has solved it, please let me know in the comment section. I'm very happy if you do it on your own, right? And okay, now to begin with. Now again, like the previous question, this one seems to create some problems, right? So what we can do with this one, we know sine square x plus cos square x is equal to 1, right? Now, even if we square on both sides, it doesn't matter because both are positive terms, right? 1 square remains 1 itself, sine square plus cos square. Now this becomes sine to the power 4x plus cos to the power 4x plus 2 sine square x cos square x, right, is equal to 1. Now this is our term, right? This is what has been in the denominator and bothering us. So let's take it this side. It becomes sine 4x plus cos 4x is equal to 1 minus 2 sine square x cos square x. And this is our denominator. So substituting it in the question, we get it sine to the power 8x minus cos to the power 8x upon sine to the power 4x plus cos to the power 4x dx. Now it's very simple. You can all see it, how we can easily do it, right? We can factorize the numerator. It's sine to the power 4x minus cos to the power 4x, right? And sine to the power 4x plus cos to the power 4x. The denominator remains the same and they cancel out, right? So the solution, the problem instead remains just this much. We can again factorize, it's giving us the option to do that, so let's do it again. And sine square plus cos square becomes 1, right? So just let's keep it at 1. Now what we can do is we can also, we can do it in multiple ways. It's okay, you can use any method which you want, right? But the easiest which I feel is just take a negative common, becomes cos square x minus sine square x dx. Now this is cos to 2x, guys, so this becomes cos 2x dx, and you can get your answer, right? So in every question, I'm repeating myself, in every question you just have to little bit tweak, the numerals, or this identity is very useful. It is used in many questions and it simplifies it easily, and that's it. Trigonometry is a bit on a higher side, heavy side, so if you don't like trigonometry, then you have to work on it, right? Okay, so let's just take one more question, and this question is not that tough, and I hope everyone will be able to do it, and if you are able to do it, I'll be really happy. Okay, so the next question. The next question says, if under root of 1 plus sine 2x, okay, it's not square guys, it's not square, it's 2x, okay, dx is equal to under root 2 sine of x plus a plus b, and we need to find the value of a and b, right? So again we want the answer to be in these terms, right? So yes, you should try it first, and once you're done we'll proceed with the solution. And if you guys come out with some other solutions, do share in the comment section, right? Okay, so we have this problem at hand. Again, what we can do is we can see that cos 2 theta is equal to 1 minus 2 sine square theta, right? Okay, uh, this won't help us over here. What we can do is, yeah, right, again the identity sine square x plus cos square x, right? This is a hint. You can use this identity again in this problem and you can easily crack it. Okay, and I'll just erase this because this is not being used in this question. We don't have cos 2 theta, we have sine 2 theta. Okay, so try with this guys, and if you are not able to solve it again, okay, we'll proceed. So what we can write is 1, we can substitute 1 by sine square x plus cos square x plus sine 2x dx. Okay, my handwriting is going all haywire. And again what we can write is sine square x plus cos square x, and we can use the formula of sine 2x, which is 2 sine x cos x dx, right? Now this again becomes a square plus b square plus 2ab, right? So this is under root of sine x plus cos x whole square dx, which we can use as under root of sine x plus cos x dx. Now this is very easy. What we can get here is minus cos x plus sin x plus c, right? But we want the answer to be in this particular form. So what we can do is, and we also see here we have a root 2, right? So what we can do is we can multiply and divide with the root 2, and let's see how it becomes. Okay, now let's keep the root 2 and bring the under root 1 upon under root 2 in the bracket. Now guys, this is another formula, and this is equal to root 2 sine of x minus pi by 4 plus c. So hence this helps us in identifying a is equal to minus pi by 4 and b is another constant c. I just, yes, what I did was I reversed these two terms. Pardon me for that. X minus pi by 4. Now it's correct. Plus c, right? So we had got the answer over here, but then the answer demanded to be in this form, so we had to do this manipulation, and this is what we have to do in almost every question. So if we are aiming CBSE, these variations will be slightly less, but then if you are going to the JEE level, yes, you have to be used to these kind of variations, right? So how do we set our mindset, right? That is the main issue. What we do is we just mug up some formulas and we try to just try to apply them in each and every question. But then I will suggest first just concentrate on the question, see what is it asking, I'm so sorry, right? And then try to approach it. Give it a minute, at least a minute in the starting. Then you'll start having a hold over it, and you will be able to solve it within seconds. Okay, one more thing is, do practice, guys. Do practice a lot. That is required, and if you do that, then only you'll be able to crack the questions. And whichever book you have, you can start with the basic NCRTs, go with the tougher ones, right? You can find it on any website. There are plenty of books which you can go ahead with, right? Just keep solving, and do come to my channel if you like it. And yeah, there uh, this is the first video. There has been some hiccups in between, some plus minus errors by myself as well, but I hope to improve, and I'll be with you guys whenever you need. You have the contact details on my channel. Do subscribe to it if you like it, and yeah, cheers. Study well. Thank you.